Hey, what's up, guys? For this, we're going to get into some buffer system questions. Okay, I know there's a lot of students are freaked out by these. I've had people take National Registry, they come back and they're like, they gave me ABG questions and it was way advanced and this and that. But honestly, it's fair for them to give you values. It's in your book, so you should know not all the values, but the three big ones you should know. But to say that they're giving you ABG questions, I think they're just overthinking it. I think you guys are just way overthinking this. So we're going to simplify it. And honestly, I mean, I remember going through paramedic school, and I needed to know, right? I'm one of those people that, I can't go from A to C without B, man. I need the B. Okay. So I remember asking people, and nobody could really tell me. I kept getting this explanation like, well, it gives and takes and gives and takes acids and keeps this homeostatic balance and this and that. And nobody could really tell me. Okay, so before we get started here, I'm gonna see if I can't answer that question for you guys. So let's draw some pictures. Okay, guys, so let me see if I can draw some pictures here. All right. So the first thing I want to start out with here is simply a cell. Okay. And the reason I start out with a cell, and I think it's important because if you really think about how this system works, right? If you take a human body and you just let it be without any balancing systems, what happens? It becomes acidic, right? Because if you think about every cell, it's a living, breathing thing. It takes things in and it offloads stuff, right? And that stuff that it offloads is acidic, okay? It has all kinds of byproducts, and all those byproducts are acidic. So what we'll do here is this will be a cell. And to keep this as simple as possible, what is the byproduct that it's going to offload, right? We're just going to say it's hydrogen. Now, yes, I know there's all different levels of acidity that these cells are going to release. Some cells actually do release CO2 and this and that, but for simplicity, we're going to say it's hydrogen. And it's important to say that it's hydrogen because right now I'm talking about a metabolic process. This is internal respiration. That's a metabolic process. External respiration, that's going to be a respiratory problem. Okay? So the cell offloads hydrogen, making you more acidic. And you need to be somewhat acidic, right? Some parts need to be a little bit more alkalinic, some parts need to be more acidic, but we're kind of in the middle, okay? And if you get too acidic, you get sick and die. If you get too alkalinic, you get sick and die. It's as simple as that. So you need a balance, okay? We need hydrogen. You need it to make all kinds of stuff. So we have hydrogen, right? But as the cells are alive and then they offload all this acidic product, well, we can't just let that be. So who comes in to save us? Right? Our kidneys, actually your chemoreceptors will detect hydrogen. In fact, it's going to be your peripheral chemoreceptors are going to detect hydrogen, whereas your central chemoreceptors will detect CO2 in your CSF, by the way, just in case you get asked that one. Um, but yeah, so your system detects acidity, and what's it going to do? It's going to release bicarb. Okay, and bicarb is, oh crap, I hit the wrong. Oops, sorry guys. So bicarb is going to be HCO3, all right? And that's bicarb. And bicarb is alkalinic. Okay, I got an acid, now I got an alkalinic. We're starting to balance out here, right? That's pretty simple. The thing about bicarb here is bicarb is kind of like a sponge. Okay, it kind of soaks up hydrogen. All right, and you don't need to know chemistry to fully understand this, but you understand 1 + 1 = 2, right? So if I take you know, this hydrogen, whoops, and he bumps into this bicarb, guess what? He's not HCO3 anymore, he's H2CO3. Okay, and let's get rid of this dude. Okay, that's pretty simple. All I did was I added a hydrogen to it. So H2CO3 is now what we call carbonic acid. Okay, that's carbonic acid. So it's kind of crazy, right? I took something totally alkalinic, I took something totally acidic, I squashed them together, and now I have carbonic acid, which is a little more alkalinic than hydrogen, but still a little acidic, more acidic than bicarb, right? Because I added another acid to it. Now, why is that important? Okay, because, well, this HCO3, which is now carbonic acid, has the ability to break up into two other things. So this actually, when it goes by where the lungs are, this guy will rip in two and then become CO2 and, that's right, H2O. That's pretty crazy, right? I took something that was totally acidic. I took bicarb, HCO3, which was alkalinic. I glued them together, and then I ripped them apart again. And guess what? Oh, come on, man. That's all good. But CO2 can now get exhaled, and H2O is simply water, right? So that just, goes back into the plasma. Plasma is like 90% water, so it just goes right in, right in hell. It can go anywhere it wants. It's water. So that's pretty neat, and that's essentially how it goes. Okay. Now the big lesson here, big lesson here that I really want you guys to grab is that respiratory acidosis or alkalosis, whatever, respiratory acidosis and metabolic are different. They are different. Do not treat them the same. So what I'm trying to say to you is that you can't grab your BVM, okay, and get rid of hydrogen. Vice versa, I can't go get me some sodium bicarb out of my drug box and get rid of CO2. It doesn't work that way, okay? Bicarb soaks up into hydrogen and then can break apart and become CO2. Yeah, that's why they're linked. Okay, that's why when you become acidic, your respiratory drive goes up because it knows this bicarb is going to bump into this guy and then become a byproduct that can be exhaled. All right. So my point is if your patient's breathing 2 times a minute, don't run and get your bicarb. It doesn't make sense. You have to bag them. You have to ventilate them. Okay, and vice versa. If somebody goes and swallows a whole bottle of Sam Club's aspirin and develops a severe metabolic acidosis, don't think that your BVM is going to get them out of trouble. Okay, it just doesn't make sense. So, yeah, there's my little exhalation guy. About time. All right, so the other thing I want you guys to get here is when you look at these two things, there's an inversion. All right. So what I mean is that this is pH, metabolic, okay? That's all that stands for, not respiratory. This is pH. So what's your normal pH values, right? It says 7.35 to 7.45, okay? So I'm going to put it here, 7.35 to 7.45, okay? Now, if I go down here, this is acidic, right? Up here is alkalinic, right? Now, if I go to capnography, which is respiratory, it's the opposite. Okay, look at your graph, right? If this is my graph, right here, this is my respiratory pattern. I like between 35 and 45. Okay, so let's say we like to be between 35 and 45. Now, if my level here, let's say my level here goes higher, that means I'm holding on to CO2. I just have more to exhale, which means this up here is acidic. And down here is alkalinic. Okay, so it's backwards. If I have a high, or let's say, yeah, I have a high number on my pH scale, that's alkalinic. If I have a high number on my capnography, or nometry, that means I'm acidic. So they're backwards, okay? So there's a little inversion there. Now, let's break this down, okay? Let's throw just a regular question at you, right? So you are dispatched, 62-year-old male, history of COPD. History of COPD, I mean, that should tell you right there. It's probably some respiratory problem, but whatever. Sitting in a tripod position, using accessory muscle. So it's a respiratory problem all day. He's only breathing 10 times a minute. I mean, that tells you right there, but whatever. Let's say you go through this question, okay, and you get to all these numbers, and it freaks you out. You're like, oh my God, they gave me ABGs. I don't know what to do. Okay, guys, so I'm going to tell you straight up, man, most of the time, if they just give you a pH value and they're like, are they acidic or are they alkalinic? Who cares? All you got to do is look at the pH value. That's the truth. All you got to do is look at the pH value. If I give you a pH of like 7.2 and then I give you a bunch of numbers and then I ask you what is their pH, like what, who cares what the other numbers are? This literally is your answer. Who cares, right? Now, sometimes, and I know, like, I've had a few students say, well, they asked me for, is it respiratory, is it metabolic, and I've even had a few ask me, is it, what is there a compensating factor? Honestly, I don't believe them. Okay, I don't think on the paramedic level you are ever going to get asked about compensating factors. I really don't. But let's say that you do. Okay, so let's say you go through this question and you're like, oh no, I'm freaking out and I have to figure it out. All right, let's say we want to even take it as far as figuring out compensating factors. Okay, so what I personally like to do when I have to figure this stuff out is I love this tic-tac-toe method. Okay, I didn't make this up. There's a bunch of YouTube videos out there on it. You go watch them, whatever. But I'll just give you a quick rundown on it just so you can kind of break this apart. But I did say in the beginning, one thing that you guys do need to know is you need to know the values. Okay, the big one here is you need to know pH. Obviously, you need to know your CO2 value. You need to know your capnography. And bicarb, yes, you need to know bicarb. But let's look at this. So if I had to figure this out, and I was really worried about, figuring out if it was respiratory or if it was, metabolic, even though I'm telling you guys, 99% of the time, the words in the question just straight up tell you. But let's say we're going to figure this out. So what I'll do is I just create a quick tic-tac-toe square. All right, and this we'll say this is acid. We'll say this one is normal, and then we'll go over here and be like, this is alkalinic. We'll just say this is basic. Okay, and there's only two categories I worry about. I need to know if it's respiratory, and I need to know if it's metabolic. We'll just put that. Okay, so pH. pH is metabolic, without a doubt. pH, 7.28, right? So the normal is 7.35 to 7.45. So that's low, which means it's acidic. So here I'll do pH. pH. I have a pH that's acidic. Metabolic acidosis right there. Let's keep going though. CO2, PaCO2, which is partial pressure CO2, that's your capnography. So we'll say capnography is at 60. Holy crap, that's acidic also. That's high. So respiratory over here, boom. I'll put capno. Capno, acidic. All right, so they're both acidic. Now, how are we going to figure out which one is the culprit? So what I'll do, we'll go to bicarb, okay? Bicarb is actually normal. You see this number vary every once in a while. It's usually 22 to 26 is your guy. And sometimes they'll tell you it's 22 to 29, but I think for the most part, 26 is more common. But either way, that's normal. And HCO3, bicarb, is going to be metabolic. Okay, so I'll actually put it right here, HCO3, bicarb. But check us out. I have acid and then normal. Okay, so believe it or not, these guys, they cross each other out, making this a respiratory acidosis. Now, if you really wanted to figure out the whole compensating factor thing, 26, first of all, is right on the line. But if you go into read some of these things, they'll tell you that if your bicarb was in the alkalinic range, so if it was high, it would say here it's a compensating factor, and here it would say it is a I'm sorry, this is actually a non-compensating factor, and then this would be compensating factor. Okay, so whatever, it doesn't matter. But either way, you have these guys in the same category, and bicarb is actually, since it's 20, it's right on the line. It's definitely compensating factor. Whatever, but with no problem though for you guys, it's capnography. But if you go back and look at your answers, the answer was C. Answer is C, being a respiratory acidosis. So just let me leave you with these three things. Please, first of all, please don't freak out about these questions. You're just overthinking them, I promise. A lot of them have freebies built into it if you just take the time to look. Okay. Number one is separate your problems. Okay, and what I mean is that if it's a respiratory problem, think about grabbing your BVM. If it's a metabolic problem, think about grabbing bicarb. Okay, don't treat one with the other. It's very important. It does not work that way. Number two, I would say, is brain dump this before you test. When you go in there, grab a piece of paper, and then right before you hit go on your exam, brain dump. Write down your values so you don't mess it up while you're testing. And then number three, please don't overthink these questions. Okay, just look for the freebies in it. All right, guys, that's it. I hope it helps. Good luck.